So today we're going to talk a little bit about inverse trig notation. We've done some problems in the past where we've been asked to take and find the cosine of what angle is equal to root 2 over 2. Well, we know that answer would be, what, if we were going in degrees, 45 degrees, and it would also be 315, right? So we know those are the answers. Well, this is another way to ask that. We say the inverse cosine of root 2 over 2 is equal to theta, which basically asks the question, once again, what angle has x equaling root 2 over 2? Okay. The other way to say this inverse cosine is arc cosine, so just be aware of that. It can be asked any one of those two ways, and your answer is always going to be an angle. So let's take a look at a couple answers. Or a couple of problems. We've got an inverse cosecant equaling 2. So if it's an inverse cosecant, we're basically asking where is 1 over y equaling 2, all right? Which basically means where's y equaling 1/2. Okay, that's going to be somewhere in the first two quadrants. So y we know is equal to 1/2. Let's just go in terms of degrees at 30 degrees. We could go pi over 6 if we want, or 150. And then if we were to take and find where is the tangent equal to root 3, we're again asking where is y over x equal to root 3. And we know that's somewhere in the first or the third quadrant. So we know we have a y of root 3 over 2 at, we'll go radians this time just for kicks, pi over 3. And we know that's also true at 4 pi over 3. Now, here's the thing. When we start talking about using our calculator to do any of this, if you were to put inverse tangent of root 3 into your calculator, you would find that the only thing that comes out is pi over 3. Likewise, if you were to put 1 divided by, or even the inverse sine of 1/2, the only thing you would get is 30 degrees. Okay, this has to do with the calculator programming, so on and so forth, and the calculator is only going to give you a singular answer. It's not going to give you multiple answers. It deals with kind of like calculators outputting functions. So let's just kind of review what your calculator is going to give you. The calculator values for inverses, they also call these things principal values. All right. For sine, cosecant, tangent, and cotangent, the only values your calculator will give you are those between negative pi over 2 and pi over 2, or negative 90 and 90 degrees. So that's all you can expect. With secant and cosine, if you're finding any inverses of those, your calculator is only going to give you answers between 0 and pi, or 0 and 180. So once again, these are called principal values, and they're the values that calculators will give you from taking any inverse. Now, let's move away from that. We're going to take a look at trying to find an exact value of some function without a calculator. We could do this with the calculator just by hitting the inverse button of cosine and 5/13, and then taking the cosine of that, and we get some kind of decimal approximation. But this problem asks you to find the exact value. All right. So we have the cosecant of the inverse cosine of 5/13. I have no idea where 5/13 is on my unit circle. I know that ratio could be found either in quadrant 1 or quadrant 4. All right, but it tells us this is in quadrant 1. So here's what I would choose to do. This is basically equal to the cosecant of a bunch of stuff. Call it happy face. All right. So I could say then that, well, the happy face is going to equal the inverse cosine of 5/13. Well, this is in inverse notation. If I wanted to get it out of inverse notation, I'd say, well, that's the same as the cosine of that happy face is equal to 5/13. Now we've seen problems like this. We know this is our x value, this is our r value or our hypotenuse, whatever, and we make a triangle from that, where we have x down here, we have our radius down there, special triangle, 12 here. Now, if all we're asked to do in this problem is find the cosecant of whatever that happy face is, all right, well, here's my happy face angle, right there, all right? And basically that's asking me for what is my r over my y value. Well, I have my r value, I have my y value, so I should be done. So 13/12 gives me the answer to the cosecant, the inverse cosine of 5/13, and that's an exact value, no decimal approximations. Let's do another similar problem. Same type problem. All right. Basically what we're looking for is we're looking for the cosine. Happy face is too hard to draw, so I'm going to call it A. Cosine of some A value. And I know that A is equal to the inverse tan of 8/15. So if I'm asked to find the cosine of A, I'm basically asked to find my x over my r value. All right. And now I know I can make a triangle because I have my y and my x value within this tangent. We know that the tan of A is equal to 8/15. So therefore, y is 8, x 15. Here's angle A, 8/15, 17 in my triples. And I'm looking for my x over my r value. Have those, x, r. So 15/17 gets the job done. Now lastly, we have a situation. Let's go back for a second. Oh, kind of messed that up a little bit. Forgot to look at what quadrant that was in. All right, so tack on, since we're in the third quadrant, cosine would be negative. All right, and now we're done. No, I skipped something. So let's go back to here. Now in this case, we don't have a number that we're finding an inverse cosine of. We have an expression. We do the problem the same way. We're looking for the cosecant of some value. We don't know what it's called. Let's call it A. So I know that A's equal to the inverse cosine of 5x. And therefore, the cosine of A is equal to 5x. Well, 5x represents some adjacent over hypotenuse type value, right? So we also know that x squared plus y squared, or sine squared plus cosine squared, is equal to 1 in our unit circle. So what I'm going to do is create a triangle with A being my angle value, right angle, and 5x being my adjacent value, and 1 being my hypotenuse. So therefore I could use Pythagorean and say that this is basically going to be 1 minus 5x quantity squared, all square rooted. Therefore the cosecant, once again, is my r value over my opposite value. So my r value in this case is 1. The opposite value is 1 minus 25x squared, square rooted. And then if I wanted to rationalize both sides, that would be the square root of 1 minus 25x squared, all over 1 minus 25x squared. Okay, hope that's enough to get you started, and I'll see you as soon as I can.